All right, let's get started with class. So this is the last lecture in Unit 5. And, we're going to be closing up this unit. So this is sustainability and project management. We had Unit 4, which was working through issues, working through that sort of thing. And then Unit 6 will be about economics and commercialization. So that's going to be a nice thing, but that'll be after fall break. So Wednesday, I'm gonna give some lectures. I'm gonna go through some lectures, some bonus lectures that I have on some other topics that are sort of niche topics I usually do in my graduate course. And so that's going to be, sort of separate from Unit 5, but it should be helpful maybe for your term papers and maybe even leading into Unit 6. So Wednesday, we'll have class, then there'll be fall break next week. So hopefully everyone enjoys fall break. It's, a nice resting time. Although, I also think of it as a time to sort of think more deeply about your term papers. And, and I'm going to assign reflection 4 today. So that's another thing you can work on. But I don't want to make it about this class necessarily. You just enjoy your fall break. And then when we get back from fall break, that Monday and Wednesday will be the commercialization and economics. And then after that, we have, I think, one more week in the semester, and I will try to schedule a time for people to do their final presentations. So the final presentations will be on Zoom. And, it'll be like, I'll try to do at least one 2.5-hour block, another 1.5-hour block, just so everyone gets a chance to present. And I want people to sort of join in, if you're want to come to the session and cheer on your fellow students or give them comments about how they're doing their project. It's always a good place to go to see the breadth of projects across the semester or across the class and what they've kind of come up with over the semester. So it's always, I've always been impressed with people's work during these presentations. And then, of course, your final paper, which will be due towards the end of the grading period for the semester, and then catching up on assignments. So we have some people in the class who still have some outstanding assignments, and check your grades in Canvas to make sure that your grades are all reported. Sometimes I miss things, especially the things on GitHub, but that's something that you will, you'll want to rectify all that for the end of the semester. So let me go into quiz 2 for a minute. So if you see this, this is our collective group issue board. So this is the Kanban board we've been working together. So you see that there are a lot of different issues going down the board. And this is because this is a collective effort. So this is all of the people in the class who have contributed to this board. You can see for each category, we have many, many issues. They're all assigned to different people. That's because those are the issues people have put on the board for their project. So I think most people in the class have contributed to the board so far, and I've graded those. So, we have different issues in different categories. So we start on the left with to-do. To-do has a lot of interesting types of issues. We have number 107, document the work process at GitHub. Number 104, regular posting and content strategy refinement. Number 116, fix UI styling. Things like 76 begin data collection, 86 begin prototyping. Creating a design system, number 70. Decide on cloud service, number 69. So these are all kind of, the types of issues I would expect, just to put in to-do. And like I said, it was to cut a cross-section through your project and maybe about 6 months into the project. And, when you're 6 months into the project, you have things that you've already done. There's sort of beginning issues. You have other things that are to do. I'm not really being that hypercritical about what issues are where, because I don't know what the scale of some of these are. I know a lot of the things are probably you have your own kind of definition of them. And indeed, a lot of people have put comments in to sort of define what they mean by these titles. So these titles, I think, are adequate. Some of the things you might want to keep in mind. Like I said, I wasn't going to grade on refining sort of the granularity of the issue, because, it's something that you just have to work out on your own. But we have offsite backups, integration with third-party health platform and devices, hold on Google's Analytics API. Those are all in the hold category. So those three, for example, they're all different sorts of granularity. Offsite backups is pretty vague in the general sense, but it gives you this sort of, you can describe what it is, and probably in the context of your project, it's, a unit of work. Because that's what you're looking for. You're looking for a unit of work, a unit of something you can do to grab and complete it in a finite amount of time. That's the whole point of an issue. Integration with third-party health platforms and devices, that's more specific, and that's on hold. And then hold on Google Analytics API. So I don't know, I don't care why they're in the hold category, just to show that you understand that some things need to be in the hold category for various reasons. Okay, so then there's the in progress category. So that we have AI algorithm development for health insights, front-end implementation, research and planning. These are all things that, again, you can put in progress. There are different levels of granularity. And of course, they're in progress, meaning that people are working on at least a part of that unit. Now, you might find out that, like, when you say front-end implementation, you get about 20% of the way in, and you find out that there are things that you need to do, maybe separate issues that need to be tackled sort of as dependencies, or maybe some things that need to happen after the issue is completed. And so that's perfectly fine. You can put those issues out. You can refine your in progress issue. In fact, a lot of people do that. Like I said, sometimes it isn't a steady march to the right of this, to the right of your Kanban. It isn't a steady march from to do to completed. It's kind of going to in progress and then reconsidering and saying, you need to move this over to hold, or we need to rethink the issue. We might move it back to do and split it into three things, which then need to be done. In progress just simply means that you're actively working on it. It doesn't mean that you've considered it. It means you're actually working. But nevertheless, sometimes you get about 20% of the way in, and you say, we need to rethink this. So we need to maybe break off some of this issue for new issues. So it's a very dynamic process. And then we have our urgent and our done. So our urgent is create backup server with VEAM, user privacy and data security compliance, implementing automated tests and code checks. So these are all things, of course, that are urgent because they may be in progress, but they need to be done very soon. They need to be prioritized. It's that prioritization that we see here. And again, this is not, this is stuff that maybe is going to be more specific to urgent. It should look urgent. Create backup server might be urgent. You can see that. User privacy and data security compliance is urgent. There's usually some quick deadline that comes up, like, can you get this done in 3 weeks, sort of thing. Usually those things aren't broken down into parts, although if something is urgent and you complete it, you say, well, there need to be follow-up things. Then you put them back in the in progress, or you put them back in the to do. Again, very dynamic process. And then done. Design the user interface, prototyping, backend complete, create a project timeline. So those are all sort of, sort of the base things maybe you would do like in the first month of the project. Really kind of getting things off the ground. And I'm not going to judge. I'm like, this is not, something I would do first. No, it's just about thinking about what are the first things you would do in a project. Those should be in done. The second things in a project, those should probably be in progress or on hold or urgent. And then the latter things you would do, those would be maybe to do. Okay. So let me zoom out here and show the beauty of this board, because I think, you don't have to take a screenshot, but it's just nice to see it. So it's very hard to read, but you can see the cards, how many cards we have here. We have a lot of things in to do, fewer things in hold, in progress, and urgent. and then fewer things are done, and that's what I would have expected. Because, this is a process where you're cutting through it about 6 months in, and there are gonna be more things to do probably than have been done, or even are in progress. So that's just a way to think about this board. Actually, technically, everyone is supposed to create one issue of each category. That's fine. So anyways, that's our board. That's our collective board. That's our work as a class. And, if you're on a team, you will oftentimes have to manage a whole bunch of contributions. So from my perspective as a project manager, I'm getting a lot of messages in my email that say, this issue's been created, this issue's been commented on or updated. And I can see all those and then go back to the board and check and make sure. And of course, that's unwieldy for a project manager. You have like 60 emails because they don't tell, I mean, and I know who they are, but it's really better to just manage it through the board. But it's even better, if you were in an organization, have a project manager sit there, maybe every week at a meeting and say, let's review these issues. Let's review them by category. Let's go through all the urgent. Or actually, we can go through the completed or finished, then the urgent, then the in progress, then the hold, then the to-do. Work backwards, because you're kind of saying, here's what you've done, congratulations. Here's what needs to be done right now, so pay attention to that. Here's what's in progress, so, kudos to people who are getting things going. Here are things on hold, so why are they on hold? Can we comment, can we clarify, maybe we can get them back on track? And then the things that are to do, which are the least important, because those are all things that maybe need to be done later. And they'll be kind of, people will just be kind of moving things from that. And so that's how you would do that in a, maybe like a stand-up meeting, some sort of sprint, or, whatever kind of agile like thing you decide to use, way to do your project board reviews. Okay. So that's all I have to say about project boards. It should be pretty easy to follow, self-explanatory, etc. So welcome back.
Was that the review for quiz 2?
Yeah, yes, I was just reviewing quiz 2. And it'll be on the recording. And yeah, I was pleased with everyone's performance on it. So yeah. So last time we talked about project automation. And then this is, of course, where I talked about these points. This is from last slide, so I'm just reviewing this. So there are a lot of things about automation in project management we have to consider. We don't want to automate everything, because when we automate everything, sometimes our return on investment is limited or non-existent. Sometimes automation can cause more problems than it solves. So we talked about where, you automate a process that needs human intervention and you leave a human out of the loop. You need to go back and repair everything or check it. And it costs you more in terms of labor than you would otherwise have if you just had a human in the loop do it. So can project management be automated? This is this article from JourneyX, and they say that there are 5 things to kind of think about. So, the first is offloading of routine tasks. So like I said before, if we're running a discussion forum, we could set up a discussion bot or like a Slack bot for stand-ups that will just ask questions repetitively, give people the same information as they need it, etc. So those are things you don't necessarily want to do manually. You also want to, you can use different types of automation, production processes or prototyping processes, usually stuff that is, really simple. So, instead of building a prototype out of like popsicle sticks, you might do some 3D printing that requires you to learn 3D printing, but you have a lot of automation in there to get things done quicker. Then there's scalability. So if you are scaling an organization from 10 people, 100 people, or you're scaling up your operation or your workflow, the scale, you can be helped by automation in terms of scaling that up. So when you have like 5 or 10 people in your team, it's easy to sort of have informal communications with them, informal meetings, conversations, take the notes, and that's when you get up to 100 people, then it's becomes time to really kind of think about automating some of them. Automating note taking or transcription or, managing discussions with bots, things like that. So that's where automation can help. Improve risk assessment and mitigation capabilities. So this really depends on you looking inward at your project and saying, where are our greatest risks? Where can we mitigate those risks? And where can we mitigate them with automation? Because remember, sometimes automation can sort of introduce risk. If you use automation for things and the automation is bad, or you don't, like I said, in a factory setting, producing like bottles of milk or toothbrushes, and you have no quality control, you just have automation instead of molding things, putting them together. And then there's a mistake and you don't catch it until later, much later, then that can hurt you because you have to spend time with all the products. So you want to really be able to do a risk assessment. You want to think about where you can mitigate the risk with automation, and then consider automation is the best way to do it. Or if it's just a matter of rethinking how you're organizing your organization. Then opportunities for efficiency gains. So we talked about that, automation. When people think about automation as being an efficiency gain, an automatic efficiency. And we think back to like our lecture on technical debt, or if we think back to last week, or last Wednesday, I talked about how a lot of automation systems can be efficient. You automate like one process, but if you automate 10 processes, that efficiency, that productivity gain is done. It's a lot of diminishing returns. Similarly, if the automation introduces more problems than it solves, the efficiency gains can be lessened. So there is a sort of a parable in here about using AI in projects, which is to say that, there are a lot of companies that want to sell AI as some sort of extension product. And this includes a lot of project management. And the idea is that, AI will give you this gain in efficiency, productivity. And sometimes it doesn't. And there have been there are a lot of companies that have invested heavily in this and then found that the investment is lacking. And sometimes that's just the way it's implemented. Sometimes it doesn't serve what they're doing. And that's important to know. Your project, you might think a large language model might help you, but it actually doesn't really matter because what you're doing is more contextual stuff and it's just generating text and it's not really fitting what you're doing. So there are a lot of ways you have to think. And then more effective communication. So automation can lead to more effective communication. It can free people up from rote tasks. It can streamline your workflow. It takes less time to do some process. You can spend more time communicating with your team, or it can facilitate communication through chatbots, things like that, that can, ask people questions and answer them. It prompts people to be communicative. But all this, of course, is in the context of your project. So depending on what your project is, you have to think about all of these aspects and how they fit into your overall strategy. So here's a good shorthand for a lot of the things I'm talking about in terms of automation. So there's this meme here where there's management as this character here, and then this balloon that's AI replacing employees. And the management is reaching for that, thinking that you can use AI instead of employees and save money and time. And so that they're very happy about that until they realize that they can be replaced in turn by management bots, which can do the same thing. And so that's, the management character is now sweating, nervously laughing. And it's just a lesson that, that strategy, if you take it all the way down, isn't necessarily viable, or it can be, you really have to strategize how you use it. Then this thing on the right that says, a computer can never be held accountable, therefore a computer must never make a management. And that I think is a truism, and of course computers are automation. And what they mean by that is like what I talked about last week. So last week I talked about like, when you have, say, like an airplane cockpit. A lot of that process is automated and hidden from the pilot. And so they can navigate this huge, panel of controls. But the trade-off for that is that they lose awareness of the outside world. So this happens with automation all the time where if you're using a lot of automation, layers of automation, you can often lose touch with your organization or some of the accountability that comes out of that. You can also have a situation where if we talked about having humans in the loop and the necessity of having humans in the loop, and how if you don't have humans in the loop, you could, with automation, just kind of running amok or doing things that you're not intending to do. We talked about the automation paradox last time, which is that the more automation you have, the more you have to have people in the loop to make sure that it works. And I think that's a good point. So that's automation. And so, again, we talk about the benefits of automation. We have increased productivity, maintaining quality assurance, reduced busy work, streamlined communication, seamless integration. So these are all the kind of the themes that we get out of this first part of the automation lecture. Now, I have the second part of the automation lecture, which I'm going to talk about automation, some related topics that are also interesting to project management. And so let's think about automation in terms of how kind of it originated, at least in terms of the Industrial Revolution. So a lot of times you'll start with some sort of manual, non-automated situation. And you'll start applying automation, to a problem. And then you'll keep adding layers of automation on it, just to make things easy. And I'm going to give this example these two examples, because they kind of get into this how once you start adopting automation, like you said, you adopt a lot of automation, there can be diminishing returns. Sometimes, though, there is this natural progression of adding automation into things, making things easier. And sometimes the return is not diminishing, but it's like, you're kind of building on what came before. So the first example is automobiles. So automobiles were the automation of the horse-drawn vehicles of the 19th century. And we have a term horsepower, which goes back to the 19th century. Horses, other pack animals to draw vehicles. And, this was the power source. And so they weren't very efficient, really dirty and dangerous. And so people started to build these things with engines. You would have this automation of horsepower, so you could produce the same power a horse could produce, but with an engine. But of course, you had engines, and then you had to figure out how to, say, more efficiently transfer energy to the wheels. You had to have things that allowed people to operate the vehicles more efficiently, and so forth. So in the 1940s, we started to see transmissions, automatic transmissions. So we had automatic transmissions that require people to shift constantly. That improved performance, that improved people's experience in the vehicle. And then beginning in the 1980s, we started to get information technology into vehicles, which automated some of this mechanical automation and automated some of the human work of driving. So this is something that's been kind of increasing. And so the idea is that you have this initial innovation, the automobile, and then to improve upon that, you need to put automation in place to make it a better experience. Now, I'm not saying that we need to be accountable to the road, but this is just an example of how you can start small with automation and build up. And word processors are another example. So word processors are the gradual automation of physical aspects of writing and editing. So again, people in the 19th century, they used mechanical typewriters, I think, for the latter half. But in the earlier part of the 19th century, they write with a pen, and it was very non-automated. And so, up until the 1970s, we had typewriters, And where the automation was happening was in streamlining that work. So you had all sorts of mechanical and electronic typewriters, and in probably the early 20th century, mid-century up until the 1970s, you had these workflows where people would, try to put together, they type documents and they use all sorts of automation to streamline that workflow. And then, of course, when software came along that was word processor quality, this is starting in the 1980s going forward, we were able to automate the whole editing. And so we were able to take software, build all the features of editing and workflow into these pieces of software. And now it's, fairly seamless. The point being is that we applied some automation to the existing technologies. Technology shifted, and you kept applying automation. So seamless experience. Now, the lesson here for project management is you might see this in your project where you have an innovation that gets incorporated into your project, and it makes for the better, and it's automation and it's better. Or, sometimes, we want to have that seamless experience. And these are examples of where you can apply automation to get that seamless experience. It's a gradual process. It builds on itself. You can't just stick a bunch of automation together and make it work. There's this logical progression over time where you're actually trying to solve problems in the thing that you solved a problem with previously. And ultimately you get to a better place. Okay. So another example I'm going to give is automation in DevOps. So DevOps is like development operations. So people who develop software developers, and their operations science that they do. So this is a combination of software development and operation science, and kind of how there's an intersection between the two. So this article talks about why and how to automate DevOps practices. And so, DevOps is this agile-based relationship between project development and IT operations, advocating better communication and collaboration between the two businesses. So this is like, where you have this sort of interdisciplinary thing in an organization. You have groups that may not talk to one another necessarily, bringing them together in a room. Of course, naturally, there are a lot of issues that crop up when you have something like this. Sometimes they're adversarial, sometimes they're just open technical issues you need to solve. And so in DevOps, we can observe that automation is driven by competitive pressures. So when you have a DevOps team, you have these two disparate skill sets coming together. They need to solve problems for the larger company. They need to solve the problems for the larger organization. They have to do it quickly, and they have to do it in a competitive way. So they really need to use automation to do that. And so, in applying automation to DevOps teams, we can see 4 outcomes. And they're mainly positive, but there are probably some negatives too. The first is that it increases cross-team collaborations. So that's one of our big challenges in an interdisciplinary team, is getting people to communicate cross teams and getting them to collaborate usefully. It also eliminates the need for large teams. So, if you think about managing a team manually, in other words, if I go out and I try to get people to coordinate their efforts, I would think, well, if I want to get some of these cross-team collaborations done, if I want to solve problems quickly, I need as many people. And of course, that's not really the best way to do it, because there are going to be a lot of internal divisions. You're going to communicate to everyone equally. There are going to be a lot of, there's going to be a lot of redundancy there, because you're kind of talking to 100 people on the team, and you're having to manage Kanban boards of 100 people contributing issues, and you're going to have to manage 100 different kind of perspectives on things, and it's very hard. In this case, we're automating this process, so we're not only automating to manage teams, but it actually eliminates the need for large teams, because we can get our small teams more efficiently, and we can get them to do things. I don't know exactly the details of this, how this all works out in practice. Number two is automating manual and repetitive tasks. We talked about that where you have tasks, it might be like working through workflow, trying to install software, trying to, try things and see if they work. You automate those, you can get those done easily. And then repetitive tasks, things that you have to do over and over. You can do that with automation. So that's a time savings. And it feeds into the managing smaller teams. Improvements to design, software development, and monitoring software functions. This is, again, these kind of baseline things. You can do things, and this is, of course, very specific to software development and working with developing software, because you can't necessarily do this with, say, other tasks like design or managing people necessarily. You can make improvements to, like if you're doing software deployments or you're trying to test software or does it, improve designs on software. Those are already well defined and those are actually low hanging fruit with respect to productivity. So we'll give them that. And then finally, it enables fast movement of development and reduces human error. So we talked about how agile is all about moving fast development, getting things quickly, getting things out the door quickly. The structure, the teams in agile allow for that. But you really need to enable it. It doesn't come naturally. So you have to do things to enable. Now, in this case, we can, if we're doing a lot of sort of software design, things that are amenable to automation, we can improve our time or performance on that in terms of time and get to our goal faster. So it actually is very consistent. But let's suppose we have a project where that's not consistent. Or we're having to manage people. Maybe we're doing sort of an artistic project where we need to manage creativity or have creativity as part of it. Automation isn't necessarily going to help us move faster. In fact, it might make us move slower. Reducing human error, of course, is also another thing where automation can get in the way. Like I said last time, automation can be both, sometimes if you give your, say you have a team of 100, you all give them automation. And the expectation is that everyone will adopt it equally. But the reality is that I can adopt, sometimes I give some piece of automation to 100 people. Some people will really embrace it and start to be a power user. Some people will kind of half use it, half not. And then some people will just reject it entirely. So you have to account for that. It's not that it gets adopted evenly. It's not that you get this even-handed sort of adoption and benefit. You're gonna have your power users, you're gonna be rejected. So you have to account for that. And sometimes just having power users is enough to give you that boost in productivity. Sometimes it is not. So that's the field of DevOps. So again, this is the DevOps, sort of the benefits of DevOps automation. This diagram on the right is from the article. And they have 5 points here. So the top benefits of DevOps automation: flexibility, standardization, consistency, scalability, and speed. Standardization means standardization, software-oriented workflows. This is where you have to sort of follow the same procedure to get to get benefits. And of course, in software, that's always a benefit. In artistic endeavors, say, maybe not so much. Consistency, meaning you don't have like things that break a lot in your workflow, which is always good, but that can be achieved, I think, without automation, although in the case of DevOps, it's required. Flexibility, meaning that it doesn't lock you into any one solution, which is good. But I don't know how, I don't know enough about this case to know how automation gives you flexibility. But you also want to have some flexibility in your process. So when you encounter new challenges, you can incorporate. And then speed, which we talked about, scalability. So basically automation enables standardization. And if you're using automation, that's really, if you ask 10 different people to use a workflow, you might get 10 different styles of using workflow. You might get 10 different outcomes. And that's a worst case scenario. But automation, if you can automate most of that workflow, those 10 people using that workflow will produce more or less consistent results. So that's the benefit of standardization. And again, now keep in mind what I said about not everyone being able to, handle automation in the same way. Some people reject it and just use the manual mode. Some people will become power users. Now, there's also this tension between standardization and adaptability, meaning that if I standardize in workflow, that means that I've automated it, it always works the same, and everyone basically gets the same output if they use the workflow. But of course, you don't want your workflow to always be the same. You want it to adapt to different conditions. So sometimes, you might have an organization where you take on different contract, and that contract work requires you to have a different output, maybe every 4 to 6 weeks. And in some industries, what they'll do is they'll build like a production line, and they'll produce some product. And then when they have a design change, they retool. They have to retool the entire line, and it costs them time and money. So adaptability is important because if you can make that process easy of changing direction, then it's not so bad. So standardization works against adaptability. There's this tension. Standardization should easily adapt to both new requirements and technological changes. Automation, on the other hand, depends on external factors, such as organizational needs and technological feasibility. So, we also have, when we talk about automation, we need to think about like, how feasible is this kind of control that we're thinking of? If we want to automate some process, is it something we can actually do well? Or is it something that's not really feasible? This is the problem with AI. You have a lot of times organizations will adopt AI, not thinking about this issue, not thinking about how it actually fits into what you're doing. How would you use it to improve your organization? Or is it just a tool, like it's a hammer looking for a nail, basically? And that's an important point, because you can't get the benefits of automation if you're trying to automate something that is a poor fit for what you're doing. Sometimes, the thing you're trying to automate requires a different tool. It's still automation, but it's a different tool. So you have to be able to figure out what tool you need to use. When we use GitHub, we have a lot of automation when we're looking at the Kanban. The Kanban board has a lot of automation. You type in things like, the name of your issue, the description of your issue, you assign it to different people, you put labels on it. And all of those things are automated. So they go and they reference some database, or they reference some set of relations platform, where they give you this relational board, this Kanban board that you can things around. You can also do things like, continuous integration of software development. So you can have like code that you can sort of make sure it's consistent. Now, all that's great for a software. But if I'm doing, again, an artistic project or something else, I might not find that automation very appealing. Sometimes it even works against me. And so version control, the way at least GitHub may not be forever. It's nice automation to have if you need it. If you don't need it, it may not be the best thing. So there are different types of version control, maybe for other types of projects that actually like that, but it's not what you're using in GitHub. So you don't get the benefit. So that also covers organizational needs. Your organization might not need automation, it might need a lot of automation, depending on what you're doing. Okay. So, then that brings me to this point, which is which things in your organization are most amenable. That's another kind of decision. Is that when you audit your organization, you say, okay, what is most amenable? And we need to think about like things that are processes that are maybe regular or need to be regularized, or processes that need to sort of stand alone, maybe things that really need to involve just human interaction, or things we can put humans in the loop on, so we might have automation that runs without humans in the loop. Maybe humans are at the end of the process. Humans, another set of automation, humans are always checking for automation, and then things that aren't automated. So that's how you kind of do that audit. But there are things in, like, say, DevOps, where, and this is just the DevOps, where they're most amenable to automation. So those are things like what we call continuous integration and delivery. This is, again, if you have some code that you can check it to see if it's consistent, if it'll run. They're consistent, there's quality control checks. There's also this continuous delivery, which allows you to put it into a framework where you can move development pipeline onto delivering it to someone so they can use it. So that's all kind of automated, and it's better to automate that a lot of times than having someone manually do a lot of this process. It really does save, but again, this is one example. Managing logs and data collection. So this is again where, if you think about data collection, it's somewhat tedious. That's why we have things like SurveyMonkey, or that's why we have things, automated forms that you get the data goes right into a database. And then, the logs are produced without human intervention. And of course, you can have errors in that. You can have non-responsive data. You can have 0 points. Those things can then be checked by a human after the fact. But having that data collection process being automated is actually far better than like someone writing all this down on a piece of paper and then transcribing it into a database and then making a bunch of errors. Sometimes, you may not want to automate some parts of it, depending on how secure the data needs to be. There are different ways that can be done in different organizations. Then there's monitoring and testing. So this is where you're monitoring something, you're testing something. Again, these are very rote tasks that allow you to sort of, take a report on how things are, and the automation can observe those things. And again, humans are in the loop checking the work. So, you might have like some cameras that you set up in your, you might be monitoring some process, some production process, or something like that. A lot of times, like if you're managing like a railroad or like a transit system, you'll have cameras on the railroad tracks or cameras on the road to make sure that it's not, a problem for your trains or your buses going on. So they inspect the tracks, inspect the road with cameras, and then that's all sort of done. They use some sort of computer vision to check to see if there are any errors, and then a human gets in the loop and verifies. And then infrastructure management. So managing infrastructure, managing cloud servers, those are all pretty obvious things for automation. But remember, again, this is something that we want to have humans in the loop. Okay, so now we think about automation and how it can be used in DevOps, and you can also do things with accessibility. Accessibility testing. If you're, say, building a website and you wanted to make it accessible to people, where you want people, say, with different disabilities to be able to read your website, they have low vision or something, or whatever, there are these standards you can use to make sure that it's up to those standards. So in accessibility testing, this is a very good way to do this. It's a very good way to apply automation. So programmers tend to automate tasks in general. So whenever you're programming, a lot of those tasks can be automated because it's just a matter of checking things, checking for specific keywords, specific things that are there, and just alerting the person writing the code that those things are present. So testing is the most automated aspect of programming, particularly for accessibility functions. So the first thing you do in accessibility testing is you have to adhere to the UIUC standards, which are these guidelines and criterion. The UIUC standards include things that are perceivable, operable, understandable, and robust. And then the automated testing that happens there should be followed by manual testing. So you don't want to just rely on the automation, you want to test the site manually to make sure those features. You can look and make sure they're there, then they have to work. And then automation is good for quantitative metrics, but bad for semantic things. So this is important. If we're looking at code or anything else, we can test quantitative metrics, we can test logical structures. But when we're dealing with semantics where there are multiple meanings of something, it's not as effective. So again, applying automation, you don't want to just rely, say, on automated testing and have no manual testing. You don't want to over rely on testing for things that maybe aren't going to be amenable to testing. Okay, so I'm going to shift then. That was kind of my slide that kind of ends my discussion of automation. And I want to get to a couple of topics about accessibility and customization. So this goes back to open source and how the open source development community can build more accessible software. So in general, we want to build things for the general public in a lot of projects. And we don't really, we kind of think about market segmentation. Like if we have people using it who are teenagers, senior citizens, or whatever. And sometimes you have user bases that are diverse. Oh, you always have user bases that are diverse. And sometimes you have special populations in your user base. So, sometimes you have, say, for example, people with disabilities, people who might need accessibility features in their website, people who, have trouble reading. There are all sorts of things that sometimes you don't anticipate. They just happen to use your software because it's good for what they do, but they need sort of support for things that are not in what's in your mind, when you're building this. So this is a GitLab blog post on how the open source community can build more accessible products. And they say that open source comes from values. And so those values should involve the point that your software should be fully inclusive. So you don't want to leave too many people. And because we're doing open source, we can do that. We can customize the software, we can make it different versions for different types of people, depending on what their needs are. And there's this quote that they give, which is the more inclusive and diverse, the better the outcome. And again, if you're using something like, proprietary product, that may not be the case, but in open source, certainly paying attention to some of the inclusion and diversity criteria make it better end product because you're using the power of sort of customization that you have. So, we can take this perspective of inclusive design. So this is very different from automation. Automation is where we're trying to standardize. And we could do that. We could apply automation to open source development and be done quickly. But we wouldn't be serving people, sometimes people who rely on us to deliver something that they can use. And so we can adopt these principles of inclusive design. The first one, of course, is that you intentionally consider and meet the needs of different abilities and workflow preferences. So this is where we're going to go in and we say, instead of automating our workflow, efficiency or scalability, we actually back up and say, okay, we're going to have sort of this design principle where we allow workflow preferences to fluctuate depending on who's trying to use it, build. So if I have a disability and I want to fork a repository for my community of people, say we're colorblind or we have low vision, and we want to fork this website, we want to design features that are specific to our needs. We want to have a workflow that caters to that. We also want to have a workflow that caters to people with different abilities to program. So we talked a long time ago about low code or no code solutions in open source. That is where you have code, you build on top of that code like an interface, and it allows people to build or manipulate the code without actually knowing the syntax or knowing rules of the program. And you might think that that's maybe going too far. But really, when you have people in these, specific populations, special populations, a lot of those people may not be techs, but they know what they know what they need. And so this kind of also, this is actually where we're using automation. Low code, no code solutions are automation. You're using a layer of automation to make the programming process easier. And that helps you with these fluctuating workflows. So there are a lot of intersections between inclusive design. The other principle is that anyone can contribute and your project should be useful to everyone, which is easy enough. A lot of open source projects at least have that promise, but not a lot of open source projects are managed in that. A lot of open source projects will consider sort of what's best for the project, the general project. And we talked about like having stakeholders in place and having people thinking about some of these things. And the problem, of course, is that we think in terms of the me. We always think in terms of the me person or the me user or whatever. Or the team that's right in front of us. We might have a core development team. And we think about those people. We don't think about people who might use it out in the open source community or out in the general. So it's always good to have that perspective, but also be honest about it. Don't just think, well, it's useful to everyone because everyone in this room of software engineers can use it. So that's some words on inclusive design. And so this is another example here. This article, 6 reasons people with disabilities should use Linux. So this is an argument sort of for people with disabilities. And in this case, you could be thinking about any disability, but I'm thinking specifically now about people with mobility issues and the sorts of devices they need to use. So like, if you know anything about like mobility devices, they can be expensive, hard to repair. If they have software on board, it may become proprietary, it may become obsolescent. And there was just a case a while back where they had these retinal implants that they had given to people, a small group of people, and they were working well, and the software became obsolete, and no one was around to fix the software, so their implants. Now that's a pretty big investment for like a company to put in the retinal implants and then have them die, so that you have to basically replace the hardware. And replacing the hardware isn't simple, it's just getting a new machine. It's like re-implanting them and everything. So this is one of the problems. And so a lot of disability related things need to have sort of open source aspect to it. So what do I mean by open source? So in this case, when you have these kind of devices for people with disabilities, they need to be reliable. So they need to be always able to work. Because if you're left, say, without a wheelchair, you can't leave the house. They have to be durable. So you're always giving them punishment. They're always enduring a lot of conditions. A lot of things like retinal and cochlear implants need to be like, something that isn't infection to the wearer. It isn't going to break, easily because it's hard to replace. So it has to be durable and then can deal with obsolescence. So we don't want to deal with obsolescence. A lot of times if you have a disability, you're on a limited income. And in any case, these technologies are so expensive, it's hard to replace. So we don't want to have them go obsolete. We want to have them have ideally no end of life. And Linux deals with that quite well. You can always upgrade the operating system on there. You'll be fine. You also want full control and ownership. So you want ownership of the intellectual property. You don't want to be locked into something with some sort of proprietary aspect of software limiting the functionality. Or you need to be able to use the software for a variety of things, sometimes well outside the bounds of what a designer or what an engineer might think is appropriate. And then finally, assistance from a large international community. So when we have, a lot of these devices, they break and it's hard to get them repaired. And so you can talk to people in other parts of the world who's maybe have had the same problem, and they might have solutions on how to fix things. So again, this is where we have this sort of accessibility imperative of projects. And it kind of runs up against the automation imperative. It runs up against the proprietary imperative. And, you know, there are the reasons why we have to think intentionally about, especially given some of these edge cases or niche cases, how we implement things, how we make decisions about how we manage our resources. And then finally, I want to talk about mass customization. So this is this article from Harvard Business Review by Gilmore and Pine. And this is where we have mass customization using 4 approaches. And these approaches are not mutually exclusive, but they do maybe overlap, but there are different ways you can do mass customization. So mass customization is where I might mass produce a product, and I might offer customization with it. So a good example is if you're using an operating system that will allow you to change the color scheme on the operating system. Or they'll allow you to change the themes on the operating system. These sorts of things. And so, you know, that's just a small example of, but it's basically where you mass produce something and then you allow people to customize it as they need. And so this helps with sort of this accessibility imperative. Automation can help because automation can manage the customization, make sure everything runs consistently. So we have 4 approaches. The first is the collaborative approach. So collaborative approach to mass customization requires the organization to maintain a dialogue with users. So it means that I want to know like what they think is important in their product. I don't want to make any presumptuous decisions. Like we said with the example of accessibility, you want to be able to know kind of what the outside world is thinking and take their opinions and work out when you design something, or at least leave it open to their interpretation. You don't want to just sit there and say, well, this group of software engineers thinks that this is sufficient, so that's all. And then oftentimes this will involve an open source community where you can solicit feedback, you can get answers from people as to what they find important. And remember, you're going to find some surprising things. The second is adaptive. So this is where users can alter the products themselves. So this is not open source per se, but this is, you know, akin to your operating system where you can change the color scheme or you can change the way that icons are displayed. It's adaptive in that if I need like to see things bigger, I can blow them up. If I can't deal with a certain color scheme and I need another color scheme, I can change it. It's not open source, but it does allow you to adapt things. Then we have cosmetic. So this is maybe more along what I was saying with in terms of different UX and UI for different users. This kind of feeds in with the adaptive. The cosmetic, though, is basically where, you know, the underlying software is the same, standardized, and you might use automation to standardize and streamline the workflow in that process. But then the cosmetic layer, which might be the adaptive layer, is different. So you might have mass customization at one layer and standardized automation at another. And that would be your strategy. Number 4 is transparency. So this is where customization is not visible to the user. So this is where, you know, you might have different settings. And, you know, you can change the settings on something so that something runs faster or slower, but it's not immediately visible to the user. So this is, I'm trying to think of a good example. But, you know, having different settings on a washing machine or something like that. Okay, I'm going to quickly talk about XR for project management. So this is kind of wrapping up some of these ideas about, you know, sustainability and kind of the future of project management, what we can do with different emerging technologies. So this is where, you know, we have these different technologies that allow us to create virtual environments. So we have these different acronyms, and I always go through these because they're confusing if I don't. There's what we call XR, which is extended reality. That tends to subsume the other three, which are augmented reality, where I might wear a pair of glasses that I can see the world, but I can generate virtual objects in them. Virtual reality, where I have like a headset which is closed, and I might generate objects within that space. And then mixed reality, where I kind of do a little. And so if you're familiar with Meta's Quest, or some of the other tools like Apple Vision Pro, these are these kind of XR platforms. So this is an emerging technology where you can do project management. And sometimes we do this to kind of generate a feeling of being, like you say, we're working from home, and we want to generate a feeling of being in the same room with our colleagues in a meeting. Or we want to do things on a whiteboard, but we don't want, we find the two-dimensional screen limited. So we end up using a virtual whiteboard in a space, and it's much more, so we feel maybe much more connected to that experience. So, this requires some technological coordination. Each person on the team needs a headset. They need to create an avatar and maintain body tracking. So there are a lot of requirements to making this successful. We can do all sorts of things, though. We can recreate project boards, whiteboard ideas, and explore three-dimensional scenes and project plans. We can use extended reality in our workflow, so we can map metadata on top of an object, and I'll show you some images in a minute. And we can participate in meetings in 3D spaces within the same location. So you might be in some other city, and I might be here in this room, and we can connect and actually share three-dimensional content. And so that has the potential to do a lot for project management, or agile, as well as some other techniques of like kind of going through plans, going through other things, but it is a sort of a high-end cost to this. So this is an example of where you have avatars who are working on this project board, this Kanban board, and those avatars are people in different locations, and they're looking into this virtual world where they're, all working on the same project, or all working on the same work. But instead of doing it on a two-dimensional screen like we did in Kanban, they're able to sort of reach up and do things with this board. So it's just giving that extra layer of presence or immersibility to it. You can also do things like inspect objects. So you can build a virtual object in this airplane engine. You can label it. This is Eon XR. This is software that allows you to take your controller and move virtual objects around, label them, explore them from different angles. And the idea is it helps you to understand the concept better than if I sent you some two-dimensional plans or pictures. You can see things up close. You can get a sense of what they are. And, it's not ambiguous, or it shouldn't be ambiguous. This is an example here of where someone's working on actually fixing something with their headset. So they have instructions up above them in the screen, and then below they're actually working on this thing that they're building. So I fixed my bike this way once. I had like this, I had my Quest 3, and I had like a YouTube video up here. I had some tools down here, and I fixed things in real time. That's actually something you can do now, but it's, again, it may be a varying value to the project. And then this is the Apple Vision Pro at the bottom right, where this guy has multiple screens. He's doing all sorts of tasks at a desk. So again, there's this value in this emerging technology, and I leave it up to you as to see how that fits into your project. And of course, we can do all sorts of, immersive planning, building models in 3D space, and then getting better avatars where we have these more lifelike avatars for people to interact with. Okay, I'm going to do a quick recap of Unit 4 and Unit 5, and then I want to go over Reflection 2. So this will be really quick, and then we'll go over Reflection 4, actually. So we talked about in Unit 4 and Unit 5, we talked about issue creation and trade-offs. So that was where we create issues. We have to think about like what they represent. Then we talked about project complexity and issue scope. We talked about the complexity of projects. We talked about different size projects and how issues relate to that. We talked about sort of development cycles and rescoping projects. Then we talked about life cycle and sustainability. We talked about thinking about projects in the long term. How, we kind of respond to hype cycles and technology. How we have to maintain our projects, and that's different from planning our projects. And then we talked about open source project maintenance, where you have a bunch of issues that come up which can threaten that sustainability. And you have to have a strategy for project maintenance to overcome those problems. We also talked about projects as a series of goals. So there are a lot of ways to deal with getting through those goals and, kind of getting people involved in your project, developing things, cycles, so that you can continually improve your project, training people to be part of the project as leaders, so that you don't lose all of your leaders and your project goes down the tubes. There was, I talked about cycles of working open. We talked about release and support cycles, feature cycle management, and contribution, or how people contribute to things, and how we might work open to do interesting things. And then we talked about software life cycles. We talked about the technical aspects of that. So how we sort of release software and we have an end of life period. We support certain versions of software at a time. We have this demo or die aspect of project life cycles. We always build demos of what our ideas, and then we reassess those demos. And we keep doing that as a way to improve our projects. Sometimes we have to modernize old and aging projects, so that requires a different skill set. We also had evaluatory methods like user path analysis, open source maturity models, and security and sustainability models. Then we talked about automation. We talked about the pros and cons of automation, some of the origins of information technology automation. And then I gave a demo with ChatGPT, which kind of talked about some of the future of project management and some of the opportunities. And then finally, in automation 2, I talked about taking automation for granted. I gave the example of DevOps. I talked about open source and accessibility, and then how mass customization can be approached. So those are all in the Unit 4 and Unit 5 notes. Go over those lectures if you need to. But for now, we're done with Unit 5. And I want to now go over Reflection 4, which will be assigned today and will be due at the end of our class periods. I think it's like December 3rd. So it's like reading. And again, I don't penalize people for being late. It's just that you want to be able to work on your final paper. So Reflection 4 is about automation. And I ask you 3 questions in Reflection 4. And these are all short answers, so I don't want you to spend a huge amount of time on it, but I want you to give me a reasonable answer that makes sense. So I want you to consider the role of automation in 3 different ways. The first one here, okay, so consider the potential role of automation in project management. Your answer should be 3 paragraphs per question or so. Your answer should reflect the different effects, positive and negative, of automation in each case discussed. So I don't want you to just give this glowing report of automation, or I don't want you to say that all automation is bad. I want you to give a balanced view of it. And think about things like technical debt or maintenance of projects or other things as well. You can bring those into the answers. So the first question is the effects of automating open source community. Now, we've talked about community management as being distinct. Managing a community of people around a project, you're trying to engage them, you're trying to bring them into the project. Now, if you automate some of those tools, like discussion groups and onboarding people and getting people involved in educating them about the project, getting them involved in leadership roles, how will automation help them? Will it help? It's a tough job because you have a lot of things. Some of them are sort of repetitive processes. some of them really require individual attention. So it's important to know what you can automate, what you can't. And that's one point. The second question is 2 points. And that is, I want you to think about the effects of automating programming. Which you remember we talked about is involving multiple projects, coordinating across multiple projects in a large organization. So say you're at Microsoft and you have all these projects under you, and you're a program manager. You're automating some of that. You're automating relationships between projects. Maybe Kanban boards for different projects. What are the effects of positive and negative? That's 2 points. And then finally, for 2 points, I want you to think about the effects of automating or automating things in a small scale project. Again, to fix that. So I guess the effects of automating managing a small scale project. So this is not like a large corporation. It's not a program role. It's not an open source community. It's a small scale project with about 3 to 5 contributors. So again, it's people sitting around a table. It could be a very small open source software. And so the effects of automating that are different. How? So is it that you automate messages? Maybe at the scale of 3 to 5 people, it doesn't make sense to automate like meetings or messages at all. Because maybe that's overkill. Maybe you're just, maybe you have to pay for the automation. Maybe it's a chatbot. Maybe it's just too much work for that. I mean, if you had like 200 people in a project, it might make sense because you're getting 200 answers, you're coordinating all of that and saving you time. But with 3 to 5 contributors, it's almost impersonal and it's just you're spending too much time per contributor on that. So, I mean, I want you to just think about this. I don't want you to like kind of, think that there's a right answer actually, because it probably is. This is a lot like the technical debt assignment where I said, I want you to find sources of technical debt in your project. You'll likely never get on top of it, but I just want you to think about it. In this case, you never know what the positive and negative effects of automation are until you actually implement. So I don't want you to worry about that. I want you to think about what are the things, maybe what the pros might be, what the cons might be. That's really, I think, the best way to be. Maybe they're all pros, maybe they're all cons, but I really want you to think about pros and at least just nominal. And then, if they don't pan out, that's fine. Okay. So are there any questions? So, I mean, you can ask questions by email if you need to. They should be live now. Let me know if it's not. But yeah, it should be live now and it's due, I think December 3rd, maybe, later if we have, like, I don't know when reading day is, like the 13th, it's late in the year. But, you have up until the end of the semester, realistically. And then I want everyone to make sure that they go over their assignments. Make sure that you have this is your sort of getting right with the assignments period. Or make sure that everything is in, look at your grades. If there's a gap, say, oh yeah, I gotta do that, or I did that, and draw my attention to it. And that'll help me out. Okay. Okay, if there are no other questions, I think that's all for today.